Hello again. Welcome to worksheet 207 gradients, and this is part 4. All right, so another problem, another gradient problem, and I need to set up my triangle. So again, I need 2 points, and I need to think about the rise, and I need to think about the run. And given that, I'm going to be able to figure out the slope of the gradient between the 2 points. All right, so first things first, I need to read the question. The diagram below represents a temperature field in degrees Celsius, and I have a little field map with some iso lines with an X and Y, and I need to do some things here. All right, so I've got my triangle set up. So the first thing I need to do is I need to figure out my field values. So my field, according to the question, is temperature. So I'm looking for the degrees Celsius. I have to be careful here. Point Y is not on the 30 line, so it can't be 30, and point X is not on the 20 line, so it can't be 20. So the first thing I need to do is I need to figure out the value of these lines. So I'm going to try doing this. So there's a 20 right here and a 20 and a 30 right here. So if I count the spaces, 1, 2, 3, 4, 5, there's 5 spaces. There's a difference of 10 there. So if I take 10 and divide by 2, I think the interval is going to be going by 2, so let me just confirm that. So I have 20, I have 22, 24, 26, 28, and 30. So yeah, that works. All right, so I've confirmed that the interval, the counting number for this field map is going by 2s. So that tells me that the X value, or the iso line with the X on it, is going to be 22 degrees Celsius. The value of the Y is going to be 28 degrees Celsius. All right, so I have my 2 points. I've got my X value of 22 degrees Celsius, and I have my Y value of 28 degrees Celsius. All right, so if I do the subtraction, 28 minus 22 is 6 degrees Celsius. Sounds familiar. So now I need to do the run. So again, the question doesn't give me any reference to distance or position of the 2 points. So I'm going to have to use the map to do it, to use the map scale. So again, I'm going to use a piece of paper, and I'm going to take that piece of paper and I'm going to line it up with the 2 points, and I'm going to mark that. So I'm marking the distance on my touchscreen between the 2 points. There it is right there. And now I'm going to take that down to my map scale. I'm going to measure it out, and it comes out to 3 meters. All right, so, this is sounding an awful lot like the last problem. So my distance is, again, 3 meters. So setting this up, I'm going to take my change in my field value, which is 6 degrees Celsius, and I'm going to divide by the distance between the 2 points, which is 3 meters. Mathematically, that's going to come out to 2, and my label is going to be degrees Celsius over meters, because that's what the labels were in my math. And that's it. All right, so I've done all the work. Let's fill out the problem. So part A is to write the formula. So I'm going to say, all right, so change in field. Actually, you know what? I'm going to make that real simple. I'm going to just do this. I'm going to say change in field. A little triangle means change, and that's going to be divided by the distance. And again, that formula is on your reference tables on the front page, right inside that equations box. So if you ever forget it, you can always just look it up. All right, so here we are back at our problem. And the next thing I need to do is I need to substitute. So my change in field value was 6 degrees Celsius, divide by 3 meters, and then calculate. Again, I get 2 degrees Celsius per meter. So that's what I would expect of the answer fields. And that's it. So to review, to do any kind of gradient problem, what you need to do is you need to figure out the value of the field values for each of your 2 points, and then figure out the distance between them. Figuring out the field values is actually pretty easy, as long as you can identify the field in the language of the question. Figuring out the distance can be a little bit more challenging. If it's only a written question, the distance has to be communicated some way in the question, in the language. The distance between the 2 points is such and such, or point X is located here and point Y is located here. In that case, you'd have to do some subtraction. On a map, we very rarely ever get the distance reported to us in the question if it's given with a field map. But the field map is always going to include a map scale, and that's what we use to figure out the distance or the run of our triangle. All right, that's it. Review this if you have any questions. Email me if you have any questions. There's always more problems that we can do for practice. Good luck.